Hi friends, today we will be starting about first year physics intermediate, that is KTG, kinetic theory of gases. See, kinetic theory of gases. See, from this chapter in MSET you will be hardly having 1 marks, and in NEET 6 marks. In NEET you will be getting around 6 marks, MSET you will be getting 1 mark. Okay. So the main motto of this kinetic theory of gas is almost it is related to chemistry. Okay. So in this, first of all, we will be dealing about Boyle's law. So what is Boyle's law actually? See, Boyle's law is nothing but PV graph, that is pressure on y-axis, volume on x-axis. If you observe carefully, it is a rectangular hyperbola for different temperatures. For example, this is T1, T2, T3. Okay? It is a rectangular hyperbola. Rectangular hyperbola. So what is Boyle's law actually? See here. Pressure of a given mass of gas is inversely proportional to at constant temperature. The pressure of a given mass of gas is inversely proportional to its volume, keeping temperature constant. That means, in other words, PV is equal to constant, or P1 V1 is equal to P2 V2. So you can see this is first graph for T1, T2 and T3. These are called as isotherms. These are called as, these lines, rectangular hyperbolas are called as isotherms. Okay? For different graphs, for T1 temperatures, T2 and T3. So this is about Boyle's law. And you can make a note here, the slope you can see it is decreasing slope. In this, the slope tan theta is nothing but dP by dV. dP by dV. That is nothing but minus P by V. Negative slope you can see. Okay? The slope is decreasing here. The tan theta is equal to dP by dV or minus P by V. This is the slope in Boyle's law. Okay? Now let us go to Charles' law. Second part. Let us go to the next one. Charles' law. Very easy chapter this one. Simple chapter. Next one is Charles' law. Charles' law. So in Charles' law, if you observe the graph, pressure versus volume, volume versus temperature, Charles' law states that the volume of a given mass of gas is directly proportional to absolute temperature, keeping pressure constant. Keeping pressure constant. That means V by T is equal to constant, or V1 by T1 is equal to V2 by T2 is equal to constant. That means you can see this is volume and this is absolute temperature on x-axis, and on y-axis you can take volume. So here the graph is a straight line passing through the horizon. So here the slope is, you can observe tan theta slope, that is dV by dt is equal to tan theta. Now how to get the slope here? We know ideal gas equation, PV is equal to nRT for 1 mole of gas. Therefore PV is equal to, what is N here? You can put N or otherwise small m by capital M, mass of the gas by gram molecular weight. In this, what I will do is I will take partial derivative. In this I will take partial derivative, that is P dV is equal to N is constant, R is constant and dt. So from this equation, what is, I will write it here, if you are unable to see, dV by dt from this one is nothing but nR by P. So this is tan theta slope here. Okay, in Charles' law, tan theta is equal to nR by P. What does it mean? That means the tan theta is inversely proportional to pressure. That means if angle is more, pressure is less. If angle is less, pressure is more. Okay? So this is about the Charles' law, and the question is also coming from this in MSET and also in NEET examinations. The question will be in this fashion. See, I will give different graphs for that one. From Charles' law, the examination questions are like this. See, on x-axis, y-axis, this is horizon. So you will be giving graphs like this, 1, 2, 3. This is theta 1, theta 2, theta 3. Here you can see, observe, theta 3 is greater than theta 2 greater than theta 1. So you can see tan theta is inversely proportional to pressure. Suppose if three graphs are given for you, that is V versus T, he will be asking whose pressure will be more. That means it depends upon tan theta. Whose angle is more, that pressure will be less. Inversely proportional. Whose angle is more, theta 3 is more. That means theta 3 more means what happens ఇక్కడ theta 3 ఎక్కువ ఉంది కాబట్టి ప్రెజర్ ఏమవుతుంది, తగ్గుతుంది. ఎక్కడైతే theta ఎక్కువ ఉంటుందో ప్రెజర్ తగ్గుతుంది. సో ఫర్ this one I'll take it as P1, P2, P3. So if you see here, what happened, P3 here, more angle, less pressure. So theta 3 is more means what happens, P3 is less than P2, less than P1. This is the answer for this one. So three graphs are given, P1, P2, P3, volume versus temperature in Charles' law. So whose pressure is more means you can see, whose angle is less, pressure will be more. So here P1 angle is, theta 1 is less. So it is having more pressure. So P1 greater than P2 greater than P3, or P3 less than P2 less than P1. This is how you have to answer the questions from graphs in MCET or in NEET examinations. Okay, clear all of you? Right. After knowing about Charles' law, let us go to Avogadro's hypothesis. What is that one? Avogadro's hypothesis. Let us see what is Avogadro's hypothesis. Okay, right. So as you know, in this chapter we are getting only 1 mark or hardly 2 marks. In MCET also hardly 2 marks we are getting. So let us see what is Avogadro's hypothesis. See, according to Avogadro's hypothesis, what he states is, so for example, you take different gas molecules. For example, you take hydrogen, carbon dioxide, nitrogen, or any other gas molecule like NH3. Okay, so for example, equal volume you take 100 ml, 100 ml, 100 ml, 100 ml. That means I have taken here H2 gas, carbon dioxide gas, N2 gas, and NH3 gas. Any gas you can take. So what the scientist says, immediate Avogadro, is equal volumes of all gases under the same condition, temperature and pressure, contains equal number of moles or molecules. That is, V is proportional to N. Here N is number of moles or molecules. Moles, that is mass of substance, which is equal to Avogadro number 6.023 into 10 power 23 atoms, ions or molecules. So here if you observe, I am taking all equal volumes. Hydrogen gas equal volume, carbon dioxide equal volume 100 ml, N2 gas 100 ml, NH3 gas 100 ml. So they will be having same molecules, same moles, X, X, X. Suppose if I interchange for this one, for example, this one H2 gas, this is CO2, suppose this is N2 and this is NH3. For example, what I will do is, initially it was taken equal volumes as X as moles. Suppose this one is 100 ml, for example. Now I will change this as 200 ml CO2 gas, and this one I will change it as 150 ml N2 gas, and NH3 I will change it as around 50 ml. Now can you tell me what are the moles present now? You have to go for unitary method. See what happens here. 100 ml contains how many moles? X moles. 100 ml contains how many moles? X moles. So 1 ml contains unitary method. 1 ml contains X by 100 moles. So here how many ml? 200 ml. So into 200, 100, 2. So 2x moles. So how many moles here present? 2x in carbon dioxide gas. In the same way, go for N2 gas. X by 100 into 150. 5 3s are 5 2s are 3 by 2x. That means 1.5x moles. The same way for NH3 gas, how much you will get? X by 100 into 50. 51s are 52s. That is 0.5x. See, you can see the moles are changed because here the ml is changed, volume is changing. According to hypothesis of Avogadro, what he has said, equal volumes of all gases under same condition, temperature and pressure contain same number of molecules. That means here in the initially I have taken 100 ml, 100 ml, 100 ml and 100 ml of NH3, N2 gas, CO2 gas and N2. But here what happened, I changed the ml here. CO2 has 200 ml, H2 is 100 ml, N2 is 150 ml and NH3 is 50 ml. So the moles also changes. For example, here x moles, 2x moles, 1.5x moles, 0.5x moles. So this is how you can explain the Avogadro's hypothesis or Avogadro hypothesis law. Now let us go to right. So till now we learned about in KTG about Boyle's law, Charles' law and Avogadro's hypothesis. We have different equations also from graphs. We learned it. Now let us know about ideal gas equation. Let us know about ideal gas equation. Now what is ideal gas equation? For 1 mole of gas, generally it is taken as PV is equal to RT. If n moles are taken, PV is equal to nRT. Now what is here n? Number of moles, that is small m by capital. The mass of the gas in grams by gram molecular weight. What is small m here? Mass of the gas in grams by gram molecular weight. So if you change this equation now, PV is equal to, in the place of n, I'll put it as small m by capital M into RT. You can see from this you can change in terms of density. What is density? Density is nothing but mass per volume. So in this, if you take away mass per volume, then the equation goes as Pm by RT. So in terms of density, it is written as Pm by RT. This is density, gas molecule. So Pm by RT, P means pressure of the gas, molecular weight, gram molecular weight, gas constant 8.314 joule by mole Kelvin and absolute temperature. This is very important equation in terms of density. Okay, very important in terms of density. Please note down. Please note down. I'll put it this one aside because this equation is very important in further Pm by RT. Okay, all right. Now let us see the next item after this density equation in ideal gas equation, that is kinetic gas equation. Very important. Kinetic gas equation. Kinetic gas equation. See now, kinetic gas equation generally for pressure it is given by 1 by 3 small m capital N U RMS by V volume. Here U is RMS velocity, N is number of moles, M is mass of 1 mole of gas and remaining 3 is constant, P is pressure, V is volume. Now in this kinetic gas equation what I will do is P pressure 1 by 3, this M, see small m is mass of 1 mole of gas. When you multiply with 1 mole of gas into number of moles which is equal to Avogadro number, this becomes as capital M, gram molecular weight. So this can become as capital M U whole square RMS by V. Now in the above equation what I will do is I will multiply and divide by 2 to get some equation. Multiply and divide by 2. So what happens? M U square RMS, okay, by V. Now if you observe carefully this equation, see here, P is equal to, I will take 2 by 3 outside and remaining 1 by 2 is there. 1 by 2 into this thing. What are this one? Half M is going to be kinetic energy. And V I will transfer here, this side. Okay, V. So finally what happens? 3 PV by 2 is equal to KE. 3 PV by 2 is equal to KE. That means this equation I will write here. PV means RT for 1 mole of gas. So 3 RT by 2 is equal to KE. Have you seen this equation? This equation is nothing but kinetic energy of 1 mole. Kinetic energy of 1 mole. And 3 you can observe, this is called as degree of freedom, F. Degree of freedom for monoatomic gases 3, diatomic gases 5 and polyatomic gases 6. 3, 5 and 6. So here you can take as general equation as F by 2 into RT is equal to KE. This is kinetic energy of 1 mole of gas. Suppose if you require n mole of gas, multiply the n. So n into F by 2 into RT. This is kinetic energy for n moles of gas. This is general equation. F is degree of freedom, R gas constant 8.314 joule, okay, by mole Kelvin. T absolute temperature, 2 is the constant value and n is number of moles. Okay, and this equation is very very important in solving numerical problems. Clear? Right. So these equations are very very important. Please make a note. Now we'll go to the next part of this KTG chapter, that is RMS velocity, that is simply called as RAM. Very very important, RAM. RAM means not computer RAM here. R means RMS velocity, A average velocity, M most probable velocity. First we will see RMS velocity. So in this equation you can see here 1 by 3, this is written as capital M because mole of gas into Avogadro number is molecular mass, capital M, URMS by V. So if you multiply this side, what happens? This one 3PV is equal to what? This one, you can see this one, M by M is equal to U RMS square. But what is PV here? PV means RT, 1 mole of gas, ideal gas equation. So this equation changes as 3RT by capital M under root is equal to U RMS. This is in terms of gas constant, absolute temperature. Now suppose if you want it in density, see already I have written the equation here. In terms of density, if you want it, see here, P into M by RT is equal to density. So here in this equation, what is RT by M? RT by M, D by C. You can change this one, see. RT by M, I will write it there. From this equation, what is RT by M? RT by capital M is nothing but P by D. Please check it. RTD, RTD, P into M. Oh, right. So, in this place of RT by M, URMS, I can write as root over 3. Instead of writing RT by M, I can write as P by D. This is another important formula. That means same RMS velocity I can express in terms of pressure and density. That is under root 3P by D. So, in RAM, R is over, RMS velocity. Let us go to average velocity now. Average velocity. So what is average velocity? See, average velocity you can write as simply average velocity I can write as root over 8RT by pi M. Average velocity of the gas molecule is given by 8RT by pi M. The same way this also I can change RT by M. You can see here. RT by I can change as root over in terms of density. 8, what is RT by M? P by D. So P by pi D. Again P pressure, D is density of the gas. This is in RAM, average velocity of the gas molecule. Last one, most probable velocity. See, most probable velocity also, I can write it, I think it's somewhere here. Most probable velocity. Okay, I'll write it here. Okay. Last one, most probable velocity, that is most probable velocity. Most probable velocity. This is given by root over 2RT by capital M. And this again in terms of density, same, pressure density, 2P by D in terms of pressure density. So, these three equations are very, very important. RAM, RMS velocity of the gas molecules, average velocity, and lastly, most probable velocity. And these equations are given in terms of pressure and density and also in the form of temperature and gas constant and molecular mass. Okay? Right. Now, let us go to the last point in this one. Last point to end up this chapter. Right. See, just now discussed about RAM, RMS velocity of the gas molecule, average velocity, most probable velocity. Okay, in different forms, in the form of densities, pressure, and also universal gas constant, also absolute temperature. But the general equation for solving numericals you will be taking for RMS velocity is root over 3 RT by M. R is gas constant, universal gas constant. That value 8.314 joule per mole Kelvin SI units. T absolute temperature and Kelvin temperature. Capital M molecular mass, which is small m into Avogadro number. 3 is a constant number. Okay. Now after this one we have left over with only small one term. That is, after the chapter will be over and we will do some 1 or 2 numericals. With this KTs will be complete. Very small chapter it is. Okay. The last one is mean free path. Last one we will be going about mean free path. Let us see what is meant by mean free path, which is indicated with the lambda m. So let us see what is meant by mean free path. You know, see, gas molecules will be going with different velocities and colliding each other. So molecules will be continuously colliding with elastic collision. Molecules will be colliding with elastic collision continuously. That means between one molecule and next molecule after collision, the gap will be left over. That gap is called as mean free path. So it is generally given by, see here, lambda m is equal to 1 by root 2 n pi d square. Root 2 constant, n is density number, pi constant, and d is diameter of the molecule. So this formula is very, very important in solving numerical problems. Mean free path means after colliding the molecules, the gap between one molecule and next molecule is called as mean free path, and lambda m is given by 1 by root 2 n pi d square. N is density number, molecules per volume, meter cube. Okay, density number means number of molecules, okay, per volume. Number of molecules per volume. That is called as, what is density? Generally mass per unit volume. Okay, so that is density number. Pi constant, d is diameter of the molecule. Clear? So this is the last point we will be studying this, that is mean free path. 1 by root 2 n pi d square. This is very important term. Don't think in any constant this one. This n is called as density number. Okay, density number. So I think this will be the end of this chapter. Now we will do a small numerical regarding RMS velocity. Small problem. Numerical. Let us do a small numerical. Note down the problem. Calculate the ratio of RMS velocities of hydrogen and nitrogen molecule, whose temperature is constant, So here what is saying is asking to calculate RMS velocity of hydrogen and nitrogen molecule. So you can use this formula. Here temperature is constant, R is constant, 3 is constant. That means what is indicating URMS? U is inversely proportional to root m. Root m means what? Molecular mass. So we will be calculating individually. First one, URMS for hydrogen. That is 1 by root. Or otherwise you can also relation. You can take a relation here. You can form a relation directly. That is here. U into root m is equal to constant. U1 into root m1 is equal to U2 into root m2. Now U1 means RMS velocity of hydrogen. U2 nitrogen RMS. M1 molecular mass of hydrogen. M2 molecular mass of nitrogen. Okay. Now see here what is U. U RMS means U hydrogen into, how to get molecular mass of hydrogen? See, hydrogen atom you can take it as 1 1. But it is H2, not atom, molecule. So the mass will be 2. Okay. So molecular mass will be taking as 2. See, it is not a atom. Atom means 1H1. It is H2 molecule. So 1H2. So mass number you can take it as 2 is equal to U nitrogen into, how to get nitrogen? See, you know nitrogen 7, 14. 7 atomic number, 14 is mass number. So how many molecules are there? 2 molecules. So 14 2s are 28. 28 is the gram molecular. Here is hydrogen is 2. Now what the problem is over? Is asking you the RMS velocity, that is U H by U nitrogen is equal to root 28 by root 2. Check up whether right or not. Nitrogen into 28, hydrogen into 2. So this one I can add under root 28 by 2. 2 how many times? 14, sir. So root 14 you will be getting, root 14. And this I think you don't have rough root, you can keep it like this. That is, we'll write it on the top better. We'll write on the top. I'll write here. I'll write it here. So RMS velocity of hydrogen by RMS velocity of nitrogen is given by root 14. Root 14 means you can write like this, root 14 is to 1. So this is the rough value of the RMS velocity of hydrogen and nitrogen molecule. Okay. So like this we can calculate any problem in KTG, kinetic theory of gases. Okay. So this is the end of kinetic theory of gases chapter, because a very small chapter as I told you in the beginning. It only carries in MSET 1 to 2 marks, and in NEET you will be getting around 6 marks. Okay. We will be meeting in the next chapter.